we've published the entire lecture online. So if you go to our website, which you can't see right now, can I get that to disappear? Is that always going to be? It's not usually there, right? Well, I guess I can. That's the address. So you can just go to our homepage, type in events, and then if you go to event number 118, I posted the lecture here. And there's unfortunately no good way that I can just send it to all your computers, so you have to go to our GitHub. Yeah, and this is the can duck under it. But that's just if you want to follow along in the lecture. If you have it installed, we can also do it like step by step. So the first thing I want you to do is to open the Jupyter notebook. And the way you usually do this, I actually don't know how you do it on Mac. I usually go to console and I type Jupyter notebook like that. And you press enter. On Windows, you should have it in your menu if you search for it. On Mac, I guess you might have it in Spotlight if you search for it.
You can also do that.
Or you do it in your terminal on a Mac computer as well. So you just go to terminal.app, I think it's called. And you type in like that, Jupyter notebook, and it will launch in your browser like Firefox or Chrome. Still not working for you, but it's working for you. Maybe you guys can like code together for this one. Just type that first part, Jupyter notebook. Sorry? Yeah, if the notebook doesn't work, you could do it just in the console. So they have at least one computer working. And we'll do it like that. Otherwise, you can just follow along also. And the lecture is online if you want to do it like later. Yeah. So when you open the notebook, you should get to a menu that looks like this, I guess. No. This. It should look something like this, and then you go to New, and you select Python or Python 3, depending on. Oh, sorry. So you go to New, and you say, I say Python default. You have something like that, Python 3, Python, something similar. And you should get, yours probably doesn't say table of contents, that's fine. If you try doing something like 4 + 4, and then press Control Enter, you should get 8. Then your Python's working.
Python Comparators?
Yeah, you could do that also. It's it depends on which packages, I think. And if you run into problems, just like raise your hand and one of us will come around and help you. So before we start programming, just take that away. So the reason we're learning about Python today, many of you might have been using like spreadsheets before. And spreadsheets are great if you have maybe a little bit of data, or you just want to enter some data and you want to do some quick visualizations. Okay, I'll just wait because there are many problems now. Okay, you're good. Okay, so spreadsheets, good when you have a little bit of data and you want to do some fast analysis, but it's hard to make more complex figures. It's hard to remember exactly what you did to get a figure, because you click things in a menu and you have to remember, oh, what did I click, which cells, how did I do what? With a programming language like Python, and this format that's called a notebook, we'll have kind of like a recipe for exactly what we did to our data in order to get certain figures. And the recipe of how we got to the figures will be saved together with the figures in the same document. So it's really easy to reproduce, both for other people that look at your data and for yourself when you come back to your data a few days or maybe like a few months down the road and you have completely forgotten what you did. You can look at this and you'll be like, oh yeah, that's it, now I remember. So one big difference between having a spreadsheet where you have a menu and you click things versus a programming language like Python is that we're actually going to type in what we want to do. That might be intimidating at first, but it's not that difficult. And once you get kind of into it, you'll like it more, because imagine that you would be talking to someone, you would know exactly what to say, but you would have to go into the dictionary and find the word and like show it to them. That's kind of how it works in a spreadsheet. Although I know what I want to do, I have to go to like the menu, I have to click data, I have to click, okay, insert this graph or something. While we're using a programming language, we can just type to the computer directly and communicate as if you're chatting with a friend of yours, like a very formal friend who has strict rules. So, okay, let's start with some basic things. So everyone were able to do something like this. And again, to run that, you click Control-Enter. And what you will see is that this is the simplest way of using Python. Like there's a simple math syntax, so you can use it as a calculator if you want. Normally, you want to do more complex things. To insert a new cell, you go to Insert, Cell Below, or you press Shift-Enter when you execute the cell. And what these cells are simply like input boxes where we input our code. So if you wanted to, I could just have one of these and write like all my code in the same one. But if I keep separate ones, I can execute them separately, and I can also write down notes in between them, which makes it easier for me when I go back to my analysis. And to show you, I will click on this cell, and we'll go to, actually, I'll use a shortcut for this. I don't know where it is in the menu. Yeah, cell type. If I select Markdown, for example, I can type notes here and I say, just added two numbers together. I press Shift-Enter, and that's going to be there as a note for what I did up there. So that was cell type, and then the one for us is code and Markdown. And Markdown is essentially a text format where you can do some like extra things, but they're not relevant for us today. Okay, so the first concept I want to talk about in regards to programming is variable assignment. Before that, just to get an idea, how many has ever programmed before? Just a little bit, tried to use R, tried to use Python? Okay, most of you guys. Cool. Then maybe we can go a bit faster. So you can go slow. Okay, if I want to assign to variable, I do something like this, a equals 5, and then I can work with that variable, and I can say, okay, a, and I get that. So instead of assigning the value 5 to a, we'll see later how we can assign an entire data set, like all our rows and columns, to a single variable, and then perform operations on that variable. But for now, This is kind of the assignment you can do. In Python, it's also possible to assign a string, a sequence of characters, which we refer to as a string, to a variable. So I could say b equals hello, and if I type out b, it'll type out hello. I'm sorry, it keeps like popping up and down. I can't fix that right now, actually. And one thing that's cool with Python is that it's really intuitive to append strings to each other just by using simple like additive operations. So if I have another string that I want to add to b, I can say, okay, b plus universe. I'll print hello universe. So it just took whatever I said in the string b and it added space universe, and the output is hello universe. So it added those two, appended that string to the other string. I can also, let's make a new cell, and feel free to make your own cells where you type down some notes as we go. But I will not do that in the interest of time. We can also do things to, for example, assign many variables and many values to one variable. So I can make a list of things, which equals, say, 1, 55, and the word hi. And then if I print out list of things, you have those three variables stored together under the same name. If I wanted to access only one of those variables, I could do something like, oh, I should also say that when I start out like that and it just appears, it's because I press tab. You can also press tab. It will autocomplete whatever you have already, whatever variable or function is already in the namespace and it's available for you to use. And it's really nice because you avoid like spelling mistakes, and it's much faster that way. And I can say now, okay, I only want first item from a list of things. I can say list of things 0. You're going to see I get that 1. In Python, when you index something, which is what we did here, you start at 0. So the first item is index 0, then it's 1, then it's 2. It's a bit intuitive at first, but once you get into it, it's really second nature, and it also makes a few things easier. The final data type I want to talk about before we get into actually working with data is what's called a dictionary. So if I make a new cell here, and I say, what do I call my different? Okay, say I want to store the colors of different fruits, because I'm interested in that. I can make a data structure that looks like this. So if I do a curly bracket or a brace, and I say, okay, I want to say that tangerines are orange and banana. Those are yellow. If I print that entire thing, it looks like it just prints the same thing that I inputted. If I want one item now, I cannot do what we did before with numbers. I have to use one of these names. So I have given it the name tangerine, which has the value orange, and the name of the key banana, which has the value yellow. So if I type banana here, it'll give me back yellow. And this is a little bit similar to what we'll go through with how you work with data. So it's a very common way of storing data in Python, so it's good to be familiar with dictionaries. Oh yeah, I should also do this because we'll do this later. Another thing you can do in Python is comparisons. So I can ask Python, is 1 equal to 1? It will say true, it is equal to 1. And what I've done there is a double equal sign, because you remember when we were assigning to a variable, we used a single equal sign. So when we're asking for equality, we need to use a double equal sign. I could also ask, is 1 equal to 0? It's not, it's false. I can ask, is 1 bigger than 0? That's true. So it's the same operators you would use in normal math, and we will use them a lot later on. So if you don't grasp everything like intuitively directly, that's okay. It's a little bit to introduce these things because we're using them, we'll use them more in a bit. Cool. Okay, so hey, welcome. Yeah, just take a seat. So that's very basic things. Most of the things we want to do in Python involves using functions that already exist. So a function is some kind of operation, some kind of recipe that someone else has made and that you want to use. For example, and functions are often contained in packages in Python. So when we install Python, we install the core of Python, and then we can install all these add-ons. It's kind of like you get your phone or you get your browser and you can install other apps to it. And the packages we'll use today are Pandas, Seabourn, and a little bit of NumPy. And we can start with importing NumPy. So it would look like this. Make a new cell. You type import NumPy. And then you press Control or Shift Enter. There's a little star there for a little bit, and then it says 18, because it's the 18th cell that I've run. And what I can do now, if I make a new one, I can type NumPy and then a dot. And if I press Tab now, I'm going to get a ton of suggestions of things I can use. So all of these, or at least most of these, are built-in functions in NumPy that I can now use to calculate something about my values. Do something that I know exists, for example, the mean. And then we do a parenthesis. That's just the syntax we use. And then we'll use one of these lists that I just showed you. So let's calculate the mean of 1, 2, and 3. Press Enter. You get that the mean value of this list of 3 numbers, 1 through 3, is 2.0. Which makes sense. So that's, in essence, how you use a function. If you think it's hard to remember all the functions, remember if you only know the first characters and then you press Tab, you'll get suggestions. And it's really powerful. If you press Enter, you insert. If you don't remember what kind of argument this function takes, so you don't know, oh, should I give it just one value or many values? You can press Shift Tab after the function shows up. And you can press Shift Tab twice, and you get a list that looks something like that. It normally shows up right here, but because my screen is a bit weird here, it pops up on the top. And it will say, okay, actually, it will say, you know, NumPy mean. It takes these different things you can put into it. And the first argument is referred to as A here. And if we scroll down in this help document, it will say that, okay, the parameter A should be array-like. So an array containing numbers whose mean is desired. And an array in this case is just some type of numbers together. There are different types of arrays, and we won't get into that. For the purpose of this lecture, all you need to know that one way of inputting an array is a list like this, 1, 2, 3. But remember Shift Tab and Tab. Those are your friends. Shift Tab to get help. And if you want a lot of help, sorry, take that away. If you want even more help, you can do $numpy.mean. And you get the same help, but it's a bigger document that you can kind of scroll through. Press the X there. A common way of using these libraries is actually not to type out the entire name every time. So we don't type NumPy all the time. Instead, we do something like, make a new cell, and they say import NumPy as NP. And then you can do NP mean 1, 2, 3. And it's exactly the same thing as up there. So basically, we're saying, okay, we want to use the library NumPy, but I don't want to type NumPy every time, so give it a nickname. Let's call it NP. Okay, so that's quick but necessary background to how Python works. And now we'll get into doing actual data analysis. The package we'll use to do data analysis is called Pandas. It does not refer to the animal. It stands for panel data, I think. And it's a term used more in econometrics or economics. And the way you import Pandas is exactly as you import NumPy. Let's take a seat. Welcome. You create a new cell and you type import Pandas. And in this case, the convention is to call Pandas PD. Import Pandas as PD. That should run for you. And now I'm going to read in a data frame or a spreadsheet-like data format. I don't have one on my hard drive, and I want you guys to be able to do it as well. So I'm going to take one from the internet. So the way this works is that we're going to create a variable that we're going to call iris. We're going to say iris equals to pd dot. Then if you press RE, you press tab, you get a few suggestions of what kind of data you can read into Python. The thing I want to read in is a CSV file, which is basically a file that has columns and rows, just like something you would look at in Excel, and there's a comma between every value. So it's a comma-separated value file. And then now I recommend that you go to the events issue and you click view the lecture online, because there's a long URL that we're going to put in. And it's kind of annoying to type it by hand, but you could if you want to. I'm going to copy it from the lecture. And I'm going to leave it up here so you can see it also if you want to type it by hand. And of course, it's like too big to see. It's a bit smaller. So if you can't find the lecture online in the events repository, you'll have to type this in by hand. So we'll leave it there for a bit. Maybe we'll take a few minutes. Yeah.
Where was it in the lecture?
Sorry?
Where was it in the lecture online? Copy it very quickly.
Stop 20.
Wait, come again? Oh, it is in Sony. That's what you said. I just repeated. And this is the, I mean, you can't see this. I've gotten the data that wants the data and wants help. Okay, cool. We can continue. Yes, Elliot. And don't worry, like if you don't have it, you can still follow along. Okay, so if I run that, it's going to run. I create a new cell, I type iris here. See that now in my variable iris, I've stored this entire data set that's really, really long actually. It's like 150 rows, and it's a little bit inconvenient that they all come out like this. So I'm going to set an option in Pandas. This is not super important. I'm doing it because it makes displaying the data easier. And the way you do it is, let's do it here. It's pd.set option. And just to, no, it's not. It's pd options. I'm going to say 10. And it's like this. So I don't always set this option either, so that's why it's a little bit. So now you see that it kind of abbreviated everything, and it shows that there's stuff here, but I'm not going to show it. The last observation is 149. Since we just start at 0, there are 150 rows in total and 5 columns, just as it says down there. Okay, now we have our data frame into Python. We can start asking Python different things. So I can ask, what's the shape of my data frame? 150 by 5. It's the same as we saw there. We can get the column names returned by doing iris.columns. And exactly as we saw up there, which I'll show you, it's we're looking at a data set of flowers. And there are different types of iris flowers, and they measured the length and the width of both the sepals and the petals. And these are the measurement values, I guess in centimeters or something. And now in Python, it's really easy to, for example, work with only one of these columns. Say I want to only look at the sepal length, I would write iris, and I would do the same kind of brackets to index as we did before. I would type the name sepal length. If you press tab, it completes. And then you press Control Enter. And you see now you only get the output of that one column instead of all 5 columns. So now I can do math on this column if I want to. Say I want to double, or I guess maybe more. I can get the square values back. I can assign them to a new column. That's iris, well, square sepal length. So this first part is like create a new column in the data frame and assign the outcome of taking this column to the power of 2. This is how you write to the power of in Python. It's 2 multiplication signs. If I do that and then I look at iris, you can see that I now have a new column that's kind of off the screen, which is the square of my sepal length. I'll keep that there so you see it. That's how you add a column and how you perform a calculation on a column. Yeah.
I'm a bit confused.
Yeah.
The iris is a structure, I mean, it's a data set.
Yeah. So iris.
Have these data with these numbers for the length and width and.
Yeah. So iris is like if you would look at a spreadsheet. Like the first row would have the names of these columns, and then the rows after that has these values. Yeah.
So how do you know, what do you call when you say iris.column, when you said iris.column, how do you know that there is such a thing as column? First, what do you call them? In MATLAB, for example, we call those after the dot, we call them fields for a structure. What
This?
do you call it?
So it's a function of that data frame, so it's called a method.
Do we even have a function of the data frame? Even if it's a data frame, we have a function.
Yes. So if you do this in another language, maybe you would write columns, or like columns and then iris. Then that would be like, okay, use the general function columns on iris. But now in Python, it's like, since this is a Pandas data frame object, it automatically is populated with certain functions that are called methods. So function method doesn't matter, but like, yes, this data frame now has a method that's called columns. And that returns the first, or the column of that data frame. Columns.
So what if my spreadsheet didn't have that first row that is the name of the.
So then it would be like the first row of values. Yeah. That makes sense?
Yeah.
Yeah.
So what I see now, when I type iris and I press tab, there's a lot of things.
Yeah, there's a lot of things.
There are things that come up. So those
Yes.
are from Pandas.
Yeah. Right.
That are available, the functions that are available to apply to this data set.
Yeah. And we'll go through a few of them now. So let's go through how to calculate the mean of, I mean, you can guess now. How do you calculate the mean? Anyone? Iris, and I do say I want the mean of sepal length. What do I type here? Yes, mean, and then the parentheses. So then it takes the mean of that one entire column. If I want the mean of all the columns, I just type iris.mean. So already we're getting to like a point where it's significantly faster than marking things in Excel and dragging and finding the sum whatever or typing out average. So that takes the mean of all the columns. You could also do something like, I'll skip that. You could.
If I want the mean of the rows.
Yeah, then you would do, if you want the mean of the rows. I think you can change your axis. Yes. So if axis is 0, that's the mean of the columns. If axis is 1, that's the mean of your rows. So there are 2 axes on your data frame, 0 and 1, because it's Python, it's not 1 and 2. And that's how you would do that. It's a good question. Another thing is maybe you want to know more than the mean of your entire data frame. You can actually ask Pandas to describe it for you. Pandas, please describe this data frame. And you'll get for each column, the 4 that were there for the beginning and the one we created. You'll get how many observations, how many rows are there, which will be the same for all of them because it's rectangular. And then what's the mean of each column, what's the standard deviation, what's the minimum, what's the 25th percentile, the 50th, the median, 75th, and what's the max value. And that's that's really quick, it's one command. It's a great kind of statistical summary of what you're working with. And another important thing is to be able to subset data. So for example, there was also a column in our data set that was called species. And one thing we might be interested in is how many different species of flowers are there in this data set. So just to recap, there's one called species, and you have 150 observations. Okay, we can already see that there are at least 2. But to find out exactly how many there are, we can type .unique. Doesn't out the complete for some reason. It'll give us back an array with 1, 2, 3 names, which are the names of these different species. Okay, yes. A common way of working with data is something called the split apply. It's called split apply combine. It means that usually I have some kind of data frame. I want to split it into subgroups. I want to apply some kind of operation on each subgroup, and then combine the results into a table that I'm presenting or looking at. So we can do that also. Instead of unique, we can use, okay, let's just make a new cell. That makes more sense. We'll type iris, you'll say group by species. If you just type enter there, it says, okay, I created a group by data frame group by object, which is not helpful in itself, but it's helpful if we do something with it. And you say, okay, now take the mean of this object. Now you're actually, for each column, you're getting the mean for each species. So what Pandas did was that it's a little bit unfortunate that thing is outside. Let me just do one thing. You don't have to do this. I just want to do this so it shows up nicer on the screen. Oh, square. So now it doesn't run off the screen anymore. So it says there are 3 species, and I already grouped them for you, and I made all the mean together. This now, like, that would be difficult to do in a spreadsheet. You can also create a new one. How do I say? You can say, okay, instead of the mean, I actually want to know how many observations were there in each group. And then you do size, and it says for each group there are 50 observations. Am I going too fast? Going too slow? Yeah?
Explain us number 58 again.
So number 58, you don't have to care about. That was, yes, I did it because I had this extra long column and it was kind of running off here. It was hard to see. So I just took it off. So you probably have a column called square or something. And this is how to take it out. You don't have to, but you could. Okay, so it's going faster than or running out of time faster than I expected. So let's go into, but we're kind of at a good spot. So these are some operations you can format the data, and you get the results as a table. Another powerful thing that we would like to do is get our result in kind of graph. Some kind of figure that percent that might be easier to look at than the data itself. And there are some things that are inbuilt already in Pandas to do this. So for the first thing, let's make a new variable. We call it species comparison. And say equals iris dot group by species dot mean. So we're going to assign this data frame to a variable name so that we can use the variable name in many functions later without having to write the entire thing out. So if I now type species dot comparison, sorry, dot plot, and I say, okay, the kind of plot I want to use is a bar plot. You should get this, and nothing should show up. The reason for this is because when you're using the Jupyter notebook, you need to tell it explicitly that I want my graph to show up in the notebook. So let's make a new cell where we say, this is maybe unintuitive, but we have to do this when we're using the notebook. It says %sign matplotlib space inline. If you run that and then run the one above again, you should get a graph like that. Someone who that does not work for? Yeah. Yeah, thank you. So we assigned a new variable species comparison, which are these means, and then we're telling Pandas that, okay, let's just plot this mean. And Pandas is using this library, matplotlib, which is a plotting library, kind of behind the scenes, so that we can use it super easily by just saying dot plot, one of those methods on that data frame also. So now we could compare it like this. We could do more complicated things also. And one easy thing we could do first is to say that maybe we don't want it to look exactly like this. We could say, let's transpose our data frame before we plot it. And then you'll see that instead of having the species down here, I actually have the variable names, and the species became the colors. So if that's not super intuitive, let's look at how that looks. So my original species comparison had different measurements here and had the species here. If you add .t, you transpose this table, which is that you switch the rows and the columns. So now your species names are up there, and then you get a different kind of plot. Depending on what you want to visualize, either one may be the better one. So this is great. Pandas has many good inbuilt libraries for plotting. There's another library called Seabourn, which has even more cool stuff. We're going to use that for a few plots now. And we do exactly the same thing as before. We say import Seabourn. So we create a new cell down here. Do that. I say import Seabourn as, and by convention, people use SNS for Seabourn. And the first thing I want to do is something called a swarm plot. You might have heard of it as a dot plot, or what else is it called? Swarm plot, dot plot, I think, or B. Some people call it a bee or hive plot. SNS. First you run that once, and then if you do SNS.sw, you get swarm plot, parentheses, and you say, okay, the data, the syntax to this, sorry, let's do this. So if you press Shift Tab, you get this help, and it says that, okay, Seabourn swarm plot, it takes one value that goes on the x-axis, something that goes on the y-axis, hue, don't care about that right now, and then data. We're going to give it x, y, and data. So first we say, okay, on the x-axis, let's put the species, comma, on the y-axis, let's put the sepal length, and then the data, oh, sorry, the data is iris. This does not have quotes around it because I've defined the variable iris. These have quotes because they're referring to columns in this data set. Around that, I get something like that. It's already pretty cool. So this is called a swarm plot. There's 50 dots in each group because there are 50 observations in each group. You can also see that the plots kind of line up. So you do get an idea of the distribution. There's a lot here, it's like thicker, and here it's more spread out. This is one of my favorite plots. I think it's really powerful. Yeah.
Is it necessary to include the x equals when y equals, since it's already supposed to?
Great question. Great point. It's not, since we're giving them, so if you remember, if you go here, I bring up the help again. The order of this argument, of these parameters, is x, y, hue data. If I specify, if I give arguments to a function in the same order that it expects them, I do not have to write x equals y equals. So I could write this as species because it knows x is going to be the first one, y is going to be the second one. However, I have to keep data here because the third one is hue. So since I'm skipping hue, I have to keep data there. And if I run that, it will be the same thing. So one of the powerful things with Seabourn is that it provides some easy ways to kind of change the visualizations of the plots, like the figure sizes, the kind of colors you use, the thickness of the lines. The way we do that, we go to a new cell and we say sns.set, and we say, okay, now we want our style to be this style called ticks. And understandably, you wouldn't know exactly all of these that exist. You need to read in documentation or the help files. I'll not go through that now, just in the interest of time, but it's quite intuitive. They have like a great web page online. Web pages are usually online. And then you go to context, and then you say the context of this. The context of this figure is that I'm giving it in a talk. And let's only set those two for now. And then we can do the exact same plot we did up there, which we just copy that row. So you can copy this row after we have changed this. So this line changes the like global configuration of plots. So now you can see that it changed the colors, and this thing's also a bit bigger. But we can do. And another thing that I usually use is this called sns.dspine. So I think it looks good. Basically, these things, you might refer to them as axes. They can also be referred to as spines. If we despine the plot, by default, you take away the right one and the top one. I like how that looks. You can also do things like, okay, let's say trim equals off, I think. And then these axes don't connect. So Seabourn provides some really intuitive ways of doing this. We won't get more into the visualization of those now, but we'll do a few different plots instead. If you copy that line, the swarm plot line, you create a new cell, and you paste it. And instead of swarm plot, we'll use something called violin plot. Violin plot. Press enter. So the analogy here is that this kind of fits a smoothing function to your dots, to your data, and says that, okay, if you don't have it like a, if I smoothen out the distribution, this is how it would look. And that thing in the middle is a box plot where you have the median is the little white dot, and then you have the percentiles and the whiskers, just as like a normal Tukey box plot. And as you notice, the syntax, like the way we specify the arguments, are exactly the same. We just use violin plot instead of swarm plot. And there are many more fun plots we can use this way. We could use what's called box plot. They look a bit ugly, but you can also change how wide they are. I like the violins and the other ones better. What we could also do, which is cool, is that we can combine plots. So say I want a violin plot, but I don't like that box plot inside of it. So there's an argument to violin. That's called inner. By default, this argument is a box. We're going to set it to none, so that there's nothing in there. We say inner equals none, so no quotes, capital N. And then they're blank. So now we could actually put something in there ourselves. I'm going to take the dots from the first plot and plot them inside these violins. A new line, sns dot. So let's just copy that instead. Take that away. swarm plot, you cannot have inner. And let's say set the color to black. Color equals black. That's something you could do. That's kind of cool. This is a plot that I would use. I would maybe tweak it a little bit more so they're easier to see. But I like seeing kind of a smoothened function of the entire distribution, but I also like seeing all the individual plots. What else? So something else we could do is so now we have been plotting only one variable, the sepal length, versus the categorical variable species. We could also plot two numerical variables against each other. For example, the sepal length versus the sepal width. So then we can use a plot called LM plot, which is for linear model plot. Say that, okay, again, we want the sepal width. It's going to be on the x-axis. The length. And then the data we want to use is iris again. It's a little bit small, so we'll change the size to be 6. And now it kind of plots all the 150 observations. If you look at this, you can imagine, you can not imagine, but you can kind of see that there are at least 2 clusters here. There's one cluster up here, and there's one cluster here. So this line doesn't really make sense here. So we can actually take away the line by adding fit regression line equals false. And you get just a scatter plot. So that's fit reg equals false. So there's some underlying structure to this data, cluster here, cluster there, as we said. We can think of things that could, does anyone have an idea of why there are clusters in this data? Because they're different species. That would be a good guess. The way we can, or like more than a guess, the way we can find out is if we make a new cell, do the LM plot again. We keep all the arguments, sepal width, length, data is iris, fit regression line is false, the size is 6, but we add one more variable that's called hue. And we say, you can think of hue as color also, like we're going to color the data points according to the species they came from. If your assumption is correct, we expect this cluster to have a different color than that cluster. It does. So the reason they cluster like this is because this, I guess you pronounce it setosa, I'm not sure. The ratio of their length and width is different from the other 2 species, which in this case kind of clusters together, so it's hard to separate them in this specific plot. But there are more plots we can do to do that. And now we could actually add the regression lines back in. So since the default argument to fit regression is true, I don't have to type that out then, I can just take it away because the default is true. And now it fits 3 regression lines that make much more sense than the one that we tried to fit to what was actually 3 different data before. Yes, we're kind of at the end. So, okay, so we only looked at the width and length of the sepals versus each other. We have also the petals and the petals versus the sepals and all these kind of combinations. We could do one plot for each of them to kind of go through it all. Or we could use one function in Seabourn to do it all for us. There's something called pair plot. And it has the similar syntax to the ones before, but since you want to use all the columns in our data set, we don't have to specify which ones to use. So again, if you look at the signature, it says the first argument is data, the second one is hue. Let's just give those 2. Let's use our iris data, and the hue is going to be by species. And I'm also going to change the size just because we want to see what we're doing. One line of code, not a lot of code. You get this. So It's a little bit hard for you to see, but this is every column in the data set. You probably have an extra column since you made that square column, which is totally fine. And so this first plot here would be the petal width versus the sepal length. The plot we just made up there is the sepal length versus the, let's go down here, sepal width. So where those two meet is up here. Remember, we had that blue cluster and then the two overlapping clusters. That was the same thing we saw here without the regression lines. And there's the line again. This is a great way to start running data when you don't know what to look for. You want to get an idea of this data set, which variables correlate with each other. Just plot this matrix of scatter plots and try to color by something that you think can explain underlying structures in the data. So we're kind of at the end. We'll go to 10 paths, right? I have some more complex stuff. Those who want can stay. It's like another 10 minutes maybe. But if you need to go, by all means, go. But that was the main part. So the thing I want to show you now is, which one was it? Yeah, let's do that. So if you look at our data set again, so I want to introduce a concept that's, so when we talk about your data set, you can talk about data sets that are wide and those that are long. If a data set is wide, it means that there's a lot of information in your columns. If it's long, it means all your information is in your rows. What that means here is that you could think of this as, instead of having at width, at length, and so on, you could have one column that says measurement, and it would say like what kind of measurement it was, if you're measuring the width or the length. And you could have one column that was like all the values. And instead of you imagining it that, I will show you how that looks. Let's go double check so we do it correctly. Yeah. So if I create a new one, I'll call this iris long, and it's the function to get a wide data frame into long format is that you melt the data from a wide to a long format. So it's called PD melt. You say what data you want to give, iris, and you say that so the ID variable, which is the variable I don't want to touch, that I want to remain constant, is the species. Because what I want to do here is I want to collapse this measurement into one column indicating what it is, and one column that holds all the values. So that is species. Then if I look at how this looks, now I only have 3 columns. Species exactly like before. Now it's something called variable. That's just the default name it gets. We could have called that measurement if we wanted to. And it indicates what kind of measurement we made. And then value indicates the value or like the amount of that measurement. And this is the maximum length our data frame can have. So now you can see instead of 150 long, it's 600 rows long. The reason we do this, it's because there are some operations in the Seabourn plotting library that are easier to perform if you have a data frame in this format. For example, the two I'll show you right now. So these are the 2 last ones we'll do. Let's make a new cell. Oops, let's not do that. Stay on page. There we go. So, okay, first we'll change the style again. So we'll say set. This time we'll use the style that's called white. The context, let's say that it's a poster now. I'll set an additional parameter that's a little bit hard to understand, but it's because we're going to make a big plot. So I just want to make sure you're available to see it. It's called an RC parameter. There's a history to that, but it's unnecessary that you know it. So let's just do what we're supposed to do and don't talk too much. Figure size. If you You can skip that RC part if you want. As I said, it's just because I want to show you a bigger plot that's easier to see. And sorry, it goes kind of off the screen. The next thing we'll do is a swarm plot again. That's the swarm plot. Now remember we have new names on the columns now. So the first one I'm going to call variable. So, and as you can see now on my x-axis, I'm going to have each column. And my y-axis is going to be the value. And now I'm going to use hue. I could type hue equals, but since, as we know, hue is the third argument, I just have to type what I want to hue by, which is species. And then my data is iris. Let's do that for an error. It's because my data is not iris, it's iris long. Okay, so now I have all the information in one plot. It's a little bit messy, like they intertwine or overlap. So I could add an argument here that's called dodge, but not dodge equals true. And it actually separates based on color. So it colors the species and then separates the colors from each other for each column in the data. So this is a very fast and powerful way to kind of describe your entire data set in one plot. And you can easily see which of these columns, for example, the petal length brings out the biggest differences between the species. If I wanted to make this look a little better, I could add SNS to spine, as we did before. I don't think it will look good if we trim it, so we won't do that. Does that kind of make sense? Okay, let's do one more plot that's borderline too much. Shouldn't.
Sorry, so we couldn't make this with the iris data?
Yeah, so the reason is, you see I'm using variable for the x-axis. That means on my x-axis, I will put the values from the variable column, which happens to be those different column names. So otherwise, I have no way of collapsing all those column names into the x-axis. Or there might be if you use a different syntax, but it's at least easier to do it this way. So yes, let's make one more. Let's copy this line where you define the style and then create a new cell. I ran it and then paste it. Instead of style white, we use a style called dark grid. Still use poster. Let's make the figure a little bit bigger. Instead of 10 by 6, we'll make 12 by 6. Now we're going to combine a box plot with a type of dot plot called strip plot. SNS dot box plot. And it's the same syntax as before. We do variable first. And then we do the value. Yeah, let's color this also. Species. The data is iris long. So that looks so very similar to what we just did, but we're having box plots instead of swarm plot. But we can change it. And what didn't I do? Okay, let's see. You can say that the colors equals C is for different shades of cyan instead of the normal colors. I mean, if you want to, depending on which journal you want to submit your paper to or whatever you like, SNS. And then we're adding another type of plot to this, on top of this plot, just as we did before. This one is called a strip plot. It's going to plot dots in, it's going to plot the dots, but it's not going to stack the dots together as the swarm plot did. Again, same syntax, variable, value. It's long. Yeah, and we have to also do dodge equals true. So, okay, they dodged. They're kind of on a straight line. We don't want that. So we want to add what's called random noise or random jitter to these plots, to these dots, sorry, so that they line up next to each other instead of straight on top of each other. That's simply a parameter that's called jitter. Jitter equals true. And they didn't go too much, so maybe we can add a number to that. Too much, to 1.2. So you can play around with this until you get something that's good. I don't remember what was good for this data set. 2. Pretty good. And we can change the color to something that looks better. Black. And now you actually get different shades of black. One which is white, doesn't make sense. But you get the idea. And there is also a way that you could, forget what I did before, but there was a way to get all of them black. I have to make a list of 3 black things, I think. Let's just look at that plot instead. So what I didn't add was, where did I add the horizontal? Okay. So if you want it in that other orientation, all you do is you switch X and Y. The easiest way for us, so right now the first one is X. If we type out that this is Y, they're gonna switch and have the horizontal one. Oh, and then we also have to say that this is hue. We also have to say that this is data, so it gets kind of annoying. Data equals. Okay, so the reason I had to specify all of them was because I didn't specify the first 2 in the order that they are expected to come. And then, yeah, then you get a horizontal box plot instead, so it's kind of easier to read the names of the columns instead of them being on x-axis.
So you want to know all these options that we have, instead you can use the help.
Yeah. So I mean, the easiest way to find out anything is to do Seabourn. If you add Seabourn Python to your favorite search engine, mine happens not to be Google, but that go, not important. And then there's an entire page with entire documentation, many tutorials, etc. And it's super intuitive. My favorite page here is the gallery, has the prettiest pictures. And then let's just do something extreme. And you could do things like this in Seabourn. And it shows you the picture, and then it's like, this is the code to make that plot. And the same Pandas also has their online library with resources. And as you said, if you're actually in the notebook, the ways to get help is to type the beginning as an S and then dot, and you get all of them like that. But of course, it's a little bit more user-friendly to kind of look in those nicely formatted documentation pages.
Last question.
Yeah.
If I want this figure now,
Yeah.
how can I access?
Again, the get the way is to right-click, say save image as. That would actually save this. That would, like, if you're in a hurry, you could also actually save it, but then you would assign it to a variable. Like, sorry. I think this is no. So now we assign the figure to variable g, and we can do something like g.save fig, I think. Oh, sorry. G.fig? Yeah, that makes sense. Yeah, so that's the call, and then you have to write in the name. So now I should probably do something like. So what happened here is that we created this figure and assigned it to G. In Matplotlib, which is the underlying plotting library, we're actually assigning what you see, which is referred to as axis, or kind of like a subplot in the figure. And then this axis belongs to a figure, which is why we do this axis belongs to a figure, save that figure. We could also have created a figure right away using a slightly different syntax. Yeah, but I'm adding, I guess I'm.
Can you bring up this name
Yeah,
PNG to see what this is?
Sorry?
Can you bring up this?
The file? Yeah, hopefully. I just don't know which directory did I start this in. So, do this. Print. Oh, so I need to go to CD. So it's there. And there are different options that you can set, like what resolution you want, as the dots, you can set as PDF, etc., etc., etc. But that's a fast way of doing it. And I actually didn't include the save part, but it's also easy to figure out, or sorry, not figure out, but find out. Yeah. That's what I have. If you guys have any questions in general, if you wanted to see something I didn't show you, I can try to make it on the fly. Or if you have any questions about what we just went through, is anything unclear? Yeah.
Have you removed a column from the data part?
Yes, good question. That's what I did quickly, but didn't really show you guys. So let's go back up to that line. So this is the syntax for removing something. So essentially what I'm saying from the iris data frame, drop the name squares sepal length or sepal length on axis 1. The reason I'm saying axis 1 is because axis 0, then we'll look through all the rows for this name. And I need to assign it back to iris because, like, I want the name iris to point towards this data frame without that column, right? Good. More questions? It's your chance to ask questions.